So we're going to be looking at complex numbers today. So some definitions really quickly. Complex number is a number system such that the numbers have a real and an imaginary component. When we write those numbers, we're going to write those as real and then imaginary. So this number out in the front would be our real number. This one, because it has this fancy little I behind it, is the imaginary component, which kind of has its own axis when we graph that in the plane, which is not something that we have to be able to do for this class. So then the imaginary unit is mathematically defined as the square root of -1. So we talked about before that we couldn't square a number and end up with a negative. This is actually what imaginary numbers let us do. We have 5i quantity squared, which is going to result in -25. So the only thing this is going to change about the process that we learned with radicals is that now, rather than telling us it's no real numbers when you get a negative under the radical, we're going to take and rewrite that as an imaginary number. And so there's a couple different places that we would do that. So the first one would be solving a quadratic equation. So the same basic steps are going to apply. You're going to isolate the expression being squared. You're going to square root both sides. Remember that when you take the square root, you get a positive and a negative, so that's an important step. And then last, any place that we have the square root of -1, we start to build out that factor tree, we're going to take and replace that with I. So a couple of examples. This first one, I don't have to do anything. It's already isolated, so the only thing I would need to do on both sides of that equation would be to take the square root. Now, when I take the square root, on the left side I get x, but again, on the right side, I'm going to have a positive and a negative square root of -27. So we're going to break that down into a factor tree. So -27. I'm going to take out the -1, which is going to give me a positive 27 that I can factor just like I did before. So factors of 27, 3 and 9, and then the 9 is going to give me a 3 and a 3. So again, we look for partners so that they can leave the house. So the 3s there have a partner. So they get to come out here with plus and -3. And then because we have this I here in our factor tree, that is what tells me that I'm going to take and rewrite this as an imaginary number. So that I is going to go out there with a 3 that left the house, and then I have the 3 that didn't get to leave, and that guy gets to stay inside the house. So everything is the same other than we have the negative, and so we have to write this with the I to take care of that square root of -1. So for number 2, we're going to have to isolate, which means I need to subtract 11 from both sides. So I would get 2x squared is equal to -48. So we can already see that we're going to have a negative number here in just a minute that we're going to have to deal with. So 2x squared equals -48. I would divide both sides by 2. So I would get x squared is equal to -24. And then I'm going to take the square root of both sides. So x is equal to positive and negative square root of -24. So we need to take and simplify that radical. So over here we're going to say -24. I'm going to take out the -1, and then I'm going to keep building the factor tree for 24. So we have 3 and 8, and then that 8 is going to turn into a 4 and a 2, and then that 4 is going to break down into some 2s. So if I start looking for partners, so there's 2s. I have a 2 and a 3 that don't have a partner, and then again right here I've got this -1, which means that I'm going to be taking and I'm going to have to write this answer with an imaginary number. So for the final answer, plus and minus, the 2's got to leave, the I gets to leave, and then I have a 3 times 2 left there that would give me square root of 6. All right, so for number 3, we got to isolate this squared component. So the first thing I'm going to do is subtract 8 from both sides. And then I have to undo that multiplication of the 4. So I'm going to divide both sides by 4. So 2x minus 1 quantity squared equals negative 2. So again, I've got to get rid of this squared. So I take the square root. So then I'm going to have 2x minus 1 equals positive and negative. Now I'm going to go ahead here because there's not going to be anything to simplify. 2 is a prime number. So the only thing that I have to do is take and bring I out in the front because I know that I have a negative 1 under there, and then I'm going to have the square root of 2 left. Okay, so then I need to add 1 to both sides. So I would say 2x is equal to 1 plus or minus I radical 2. And then I'm going to divide both sides by this 2. So that cancels. This is your final answer. So again, you could take and you could write this as 2 separate solutions. We could say 1 plus I radical 2 over 2, 1 minus I radical 2 over 2, or you can leave it as a single solution. The other thing you want to go back and think about is when we did quadratic formula, we had to look at these fractions in the front. So I would always check the 1, see if there's any coefficient on I, and check that denominator to see if there's anything to simplify. But in this case, we don't have anything to simplify. All right, so then adding, subtracting, and multiplying complex numbers. So we're going to distribute. You can use the box method if you need to. We're going to combine like terms. When we talk about like terms, we're talking about real components and imaginary components. So just like we have x and x squared, and those two things can't be added together, real and imaginary components cannot be combined together. We're going to replace I squared with negative 1. So that can be a little bit confusing because a lot of times what we think about is that when I take and I multiply a radical by a radical, we take and tell you that you can multiply what's under the radical together and then it's going to be the same. Now, this does not happen here with your square root. For this one, the squared roots basically turn into something squared, and then that's going to result in negative 1. So it's a little technical. Just kind of have to trust us on the fact that that's going to be negative 1. All right, so for this first one, again, if we're following subtraction, and this is in parentheses behind this on number 4, you have to be really careful with signs because this is going to be subtracting a negative or negative 2i. So one thing that I do is I take and I change that sign in the middle to a positive, and then I change the sign of everything behind it. It's almost like you distribute the negative with multiplication. It's not even like it is. And then I'm going to take and combine like terms. So 3 plus negative 8 is going to give me a negative 5. 7i plus 2i is going to give me 9i, and that would be the final answer. For number 5, again, I just combine the real components. So 7 plus 2 is 9, and then 5i take away 2i is going to give me 3i. So for number 6, it gets a little bit different because now we're taking and we're multiplying together. So we have 4 things that we're going to multiply together. So to help us make sure that we keep some of that organized, we can use and set up a box. So we would have 2i up here at the top. I can put the negative 5 and 2i here. Just make sure you're really careful when you take your signs with those for the multiplication. So then I'm going to multiply the negative 5 and the 2, and that's going to give me negative 10, negative 5i, and then 4i in the bottom left. So then if I multiply 2i times I, anything multiplied by itself is squared, so that's why this becomes 2i squared. So again, because I have 2i squared, I can take and rewrite that I squared as negative 1. So really what we have in this bottom box is 2 times negative 1, which is negative 2. So then when I think about taking and combining the like values together, Negative 10 and negative 2 is going to give me negative 12. 4i and negative 5i are going to combine to give me negative 1i, and so that would be my final answer as a complex number. For number 7, if you don't want to draw out the box, you could take and make sure that we're just following distributive property. So distributive property tells me I have to multiply 3 times 5, which is going to give me 15. I also have to multiply 3 by negative 2i, which is going to give me negative 6i. Then I'm going to take and multiply the opposite of I, so that's going to be negative 5i. And then negative I times negative 2i is a negative times a negative gives me a positive, and this is 2i squared. So again, because I have I squared is going to become negative 1. So as I'm working through and simplifying, 2 times negative 1 is negative 2. I'm combining 15 and negative 2, which is going to give me 13. And then I have negative 6i minus 5i here in the middle, which is going to give me negative 11i. So again, you can use whichever of those processes is a little more comfortable for you. It doesn't make any difference. Just make sure that you're multiplying the correct number of things together. All right, so dividing complex numbers is not quite as simple as the other two. So there's a couple different things. If you have I as a monomial, so one term of the denominator, then you're going to take and you're going to multiply the top and the bottom of that fraction by I. So that's something that's going to look like 5 over 2i as an example. If I is part of a binomial of the denominator, so 2 terms in the denominator, then we're going to take and we're going to multiply the top and the bottom by what we refer to as the complex conjugate. So your complex conjugate of the denominator is the same expression but with the opposite sign. So you can think about our radicals. We had to multiply radicals by a conjugate in order to simplify those in the denominator. So we're doing the same thing here with imaginary numbers. So that would be something that looked like 5 over 1 minus 2i. Again, we're going to take and look for any place that has an I squared. We want to take and replace that with a negative 1 and then simplify it. So let's look at a couple of examples really quickly. So we have 3 over 4i. So that's a monomial in the denominator. So in order for us to not have I in that denominator, I'm multiplying by I over I. So your numerator is going to be 3i. Your denominator would be 4i squared. So again, when I multiply that I by itself, it becomes I squared. I squared is negative 1. So what we're thinking about here is that I have a negative 4 in the denominator. Now, I'm positive divided by a negative, which means my final answer is going to be negative. So I can put that negative out here in the front, and then I would have 3i in the numerator, and I would have a 4 in the denominator. I'm going to go ahead and jump down here to number 10, since it's the same type of problem. So again, I have 7i in the denominator, so that means I need to multiply by I over I. Now, that means up here in the numerator, I'm taking and distributing that to this entire expression. So when I distribute that, I get 2i minus I squared over 7i squared. So again, any place that I have I squared, that's going to become negative 1. We're going to have to be careful with some signs here in just a second. So this becomes 2i minus a negative, which is really addition. So that numerator is going to be 2i plus 1 over, and then this is 7 times negative 1. So that again is a negative. I can put that out here in the front and make that 7. So let's clean this up a little bit because I want the real component in the front. So negative 1 plus 2i over 7 is the final answer there. So for number 9 and 11, we're taking and we're looking at our complex conjugate. So again, it's the same expression. All I'm doing is taking and changing the sign. And then I have to multiply top and bottom by that because anything divided by itself is 1. So this operation is not actually changing the value. I'm just taking and making it into the way that I want it to be. So again, if you're using the box, we have to multiply that numerator together. So that would be 6 and 4i and 2 and negative I. So I'd have a 12, 8i, negative 6i, negative 4i squared. And so then again, as soon as I see that I squared, I know that that's negative 1. And so then we are going to combine like terms. Now again, this is just the work for the numerator for that multiplication. So 12 and then negative 4 and negative 1 make that a positive 4. So 12 plus 4 is going to give me 16. 8i and negative 6i is going to be positive 2i over. This denominator is a difference of squares, essentially, right? When I take and multiply this together, the middle two terms are going to cancel out. So that's actually why we multiply by the conjugate. So that allows me to get rid of that term that has the complex number in it. So really quickly over here, if I were to take and multiply that out with a box, I would have 4, 2i, negative 2i, and then this one's going to be negative I squared. Well, these two cancel out because it's a positive 2i and a negative 2i, so I'm just left with 4 and negative I squared. Well, I squared is negative 1. A negative times a negative makes it a positive, so it's actually a positive 1 here. And then I would add 4 and 1 to get, I feel like I just confused myself there. 4. Because that would be minus I squared. That's a lot there. So that's minus I squared. So let's work this over here so we don't get you confused. I just kind of got myself a little confused. This is, again, is negative 1. So I'm subtracting the negative, which turns it to a positive. So I'm going to have 16 plus 2i over 5 as your final answer. All right, so let's try here for number 11. We're going to have 7 plus 5i over, oh, it's not what we want. We're multiplying by the denominator. So 1 plus 4i divided by 1 plus 4i, that's our complex conjugate. So I'm going to just distribute. I'm not going to set up the box for the numerator. So 7 times 1 is 7. I would have 7 times 4i, which is 28i, plus 5i, plus 20i squared. As the numerator, denominator would be 1 plus 4i minus 4i plus, minus 16i squared. So again, that's just multiplying those 4 things together. If you set it up and did that in a box, then you should see the same 4 things that I got when I multiplied that together. So I squared, negative 1, negative 1, and then we're going to take and simplify and combine like terms. So that's a negative 20 and 7, which is going to make that negative 13. 28i plus 5i is going to give me 33i divided by, so these two terms cancel. This is going to be negative 16 times negative 1, which is positive 16, and 1 plus 16 is going to give me 17. So again, that's operating with complex numbers, so adding, subtracting, multiplying, and dividing, and then also using that to solve some quadratic equations.